Hello, my dear students. Sir Patrick welcomes you all to today's lesson. Our lesson for today is on the topic sets. So we'll be looking at sets and operations on sets. Let's look at our lesson objectives. By the end of the lesson, the student will be able to 1. Determine and write the number of subsets in a set. 2. Identify the properties of operations on sets. So by the end of this lesson, you, my students, must be able to determine and write the number of subsets in a set. And 2. Identify the properties of operations on sets. We'll be looking at subsets. So what is a subset? A set M is said to be the subset of another set N if and only if all the elements or members of M can be found in N. Subsets are denoted by this symbol or this. For example, if N is the set of natural numbers from 1 to 7 and M is the set of even numbers below 7, then M is a subset of N because all the elements of the set M can be found in the set N. So M is a subset of N. This is how we write it. M is a subset of what? N. So this symbol is what? Subset. With this one too, N is a superset of M. N is a superset of M. As I said earlier on, a set is said to be a subset of another set if all the elements of that set can be found in the bigger set. So A here, set A here is a subset of what? The set B. Since all the elements of the set A can be found in what? The set B. So the set A is found in what? The set what? B. As you can see from this picture, that the set A, this region is representing what? The set A. So it's been found in what? The set B. Since it's what? A subset of what? B. So with this one, A is a subset of what? B. And B, set B is a superset of what? Set A. Another example. Given that set A has the element 1, 3, and 5. Set B has the element, that's what the set of natural numbers from 1 to 5. And the set C has the element 2 and what? 8. We could see that all the members of the set A can be found in what? The set B. But not all the elements of the set C can be found in what? The set A or the set B. So with this one, A is a proper subset of what? B. But C is not a subset of B or A. So C is not a subset. This symbol means what? Not a subset of B. Let's continue. Listing the subset of a set. The empty set and the set itself are the first two subsets of every set. So to list the subset of every set, the first two are what? The empty set and what? The set itself. So the empty set is a subset of what? Every set. Let's continue. The other subsets include each element of the set. So after the empty set and the set itself, the next one is what? To form a set containing what? Each element. That will be what? Subset of what? The set. And now a combination of what? A combination of the elements in twos, threes, until each and every element combines with other and other elements. Note, the number of subsets in a set can be found by the formula 2 raised to the power n, where n is the number of elements in the set. So in order to know the number of subsets that you can find from what? That you can form from a given set, is what? Just by the formula 2 raised to the power n. So n here is what? The number of elements in the set. So to find the number of subsets in an empty set, it will be what? 2 raised to the power what? 0. Since what? The set is what? Empty, there's no element in the set. Now finding the number of subsets of a set. For example, the first example, if M is a set that contains the elements X and Y, list all the subsets of the set M. I said earlier on that an empty set and the set itself are the first two subsets of what? Any set. And I also said that to find the number of subsets, we use the formula 2 raised to the power n. And with this one, the set M has what? 2 elements. So our n here is 2. So it will be what? 2 raised to the power 2. Which will be what? 4. So the number of subsets of set M is 4. Now let's begin with forming the subset. We have what? Our empty set, which is this one. The set itself. So this one is the same as what? This. So this was the set itself. And what? The set of what? Every element of the set. So the set containing only X and the set containing only Y. And the combination of what? The element in twos. So since we have only 2 elements, this is what the combination X, Y. So this set has 4 subsets. The second one, find the number of subsets in the set. The set of natural numbers from 1 to 4. So this set has 4 elements. So the number of subsets will be 2 raised to the power 4. So we have our empty set, the set itself, a set containing each element, the combination in twos, in threes, and what? This is in fours. So the number of subsets is what? 16. We have 16 subsets from this set. Now, evaluation. You, my students, should be able to do this one. If A is a set of natural numbers from 1 to 3, B is what? A set that contains the element 2, 3, and C is a unit set. So it has only one element. So it's what? A unit set containing only 3 as for the element. Determine which set is a subset of the other. Second one, how many pair of subsets are there in the set of factors of 18? So the set of factors of 18, how many pairs of subsets can you form from that set? Good luck, my students. We are moving on to properties of operations on set. When 2 or more sets are combined together to form another set under some given conditions, then operations on sets are carried out. So we carry out operations on sets when we combine 2 or more sets. The following are the important properties of set operations: the commutative property, associative property, then what? Distributive property. Now let's take a look at the commutative property. The commutative property, for any 2 finite sets A and B, then A intersection B is equal to B intersection C. So this is what? Intersection. Then A union B is equal to B union A. So with intersection and union of 2 sets are commutative. For example, let's consider the set A with the elements 1, 3, and 5, and the set B with the elements 1,